Enteric CH4 production can be influenced by diet, animal, and management factors. Another environmental concern for the sheep industry is nitrogen excretion, which is a considerable source of nitrate and nitrous oxide outputs responsible for groundwater pollution and global warming. Materials and methods. Animals. 48 lowlands lamps were used in a completely ransomed design. 23 zircon with a factorial arrangement of treatments. 2 breeds Highlander versus Texel. 3 sexes feral versus intact male versus wither. 2 diets fresh grass versus fresh grass plus 0.5 kilogram dye pellet concentrate. The 48 sheep were blocked in time in 5 groups when run through the 8 chambers with 1 sheep per chamber in sequence. Diets. Fresh grass was harvested from the first route of parental ryegrass. Sward of over and Lipton. The availability and consumption of forage were measured. Metabolic rates. The 84 animals were individually housed in pens in 8 groups in sequence with 5 sheep for each. Time according to their schedule and chambers, and feed experimental diets for 18 a before begin transferred to individual calorimeter chamber for a further 4 day with feed intake, fecal and ion outputs and CH4 emission measured. Measurements. Dial feed intake was recorded. Body weight before entering and after leaving the chamber. Rhythmological analysis of grass and fodder. Feces and urine outputs were recorded daily during the 4th day in the chambers. Measurement of nitrogen on a fresh basis immediately after the collection and biochemical analysis. The animal remaining in the chambers for a 4th day with measurement of CH4 emissions. Statistical analysis. Data were analyzed as a completely randomized design with a 2-breed 4-3-6-4-2 diet factorial arrangement of treatments using general ANOVA for evaluation of effects of breed, sex, and diet types on feed intake, nutrient digestibility, CH4 emissions, and night utilization. Results and discussion. In the table 5, it shows a little reduction in methane emission in treatment that it's only triggers. It shows most nitrogen retention in the treatment that eats grass and a concentrate. The treatment that eats grass and concentrate shows more estrogen in feces than the treatment with ryegrass. The other table shows most meter emission for a level than Highlander. However, there are no significant differences. Conclusion: digestion of food depends on the quality of the product. Mahar and the F in the pasture present greater digestion. The supplement treatment present higher emissions of CH4. High quality fodder can reduce emission.